Carlos Lopez. I am studying electronic engineer. My code is 2143071. I am the programming group L1. Today I come to expose my final test. Description of the problems. Medical students have established that a bungee jumper's chance of sustaining a significant vertebral injury increases significantly if the free fall velocity exceeds 36 meters of seconds after 4 seconds of free fall. Uh, Part 1. Find the maximum mass the bungee can hold without being a health risk for the jumper. Solutions. After reading the rule, I will proceed to explication of the solution. In my case, I create a menu of 5 items. 1. Show the critical mass. 2. Show the base of the jump. 3. Show velocity versus time graph. 4. Show critical mass versus drag coefficient graph. 5. X. Define a function to define the general equation of the velocity. In the case gravity is constant, the time constant is as false equations. The time is 4 seconds. The drag coefficient is 0.22. Gravity is constant, 19.81. And in two counters. On the one is for bake and the other is for the velocity. I think onward. To the left makes with two safeties with the tent. I think while if the speed is less than 36. The variables to use the counter. And then again the set the speed equations new. If the speed is greater than 36 again invoke my account the give print to the now what the critical mass run. The critical mass is 125.6. Part 2. Tells Will's time of the die of is after, for example. The jumping according the table is variation for CD solutions. Pebmuse we use the cultural dates. I define a variable which go CDS. They give print to new. What that thing define the variable speed and mass to make an accountant. Then I think another variable to invoke the date table. We use the logs to do me tour by the dates table. Then I define a variable to the part of the date table and then define a variable b. The date table then I define a variable to the part of the date table and then define a variable b which define general equation and give print. This is the table of CDS. The best hour to the jumping is at 15. Part 3. Make a graph of the velocity v again times t. Write the difference variance of mass. Multiply graph in the same plot. Solution. Import to our library, NumPy, which is used to call the trigonometric functions, and MATLAB pilot library for graphite. In this case, the constant drags gravity the constant grass is constant. Gravity is constant. Then income sets random weights take time variation in range of 0 to 10. I define the velocity equation for the sets maze, which I define my independence variables, time, and dependent variables, speed. I assign a color to each functions: red, blue, black, green, seems, maroon. Rand. Insert the volume mass M1. Fourth fight. Insert the volume mass M2. 50-50. Insert the volume mass M3. 67th. Insert the volume mass M4. 18 seats. Insert the volume mass M5. 19 seats. Insert the volume mass M6. 14-3. My graph time versus velocity is. This is parts fourth. Make a graph of the variation of critical mass against the variation of drag coefficient. Solutions. In this case, we use the same library to plot. Time is constant. Then income its random weights takes the time variations, and time is constant in the case. By finding the mass critical in H, define variables drag coefficient C, and the antin use the loop to do as with 4 hours of city table. Then define the city variables using the dates in the coefficient of drag. Use a while loop. So that this condition is met if the speed is less than 36 in bulk. The variable amps then again invokes the equation of the speed. If the speed is less than 35.9, I call my account Saint give prints. I define G and adds as a matrix break if I give. Then again set the speed equations. To define the critical mass to graph coefficients, define the matrix of the independence variables in X, and the matrix of the dependence variables bakes to lab. Rand. This is the file CDLs. My graph is this is. Thanks to hold for viewing my video. I thank you if you give like. Bye bye.